Hello and welcome to Inside Data and Access Policies for Azure SQL and SQL Server here at Data Platform Summit 2022. I am Andreas Wolter, Program Manager for Azure SQL and SQL Server Security, and in this session I'm going to show you some of the internals of how we got access policies based on Purview working inside the SQL engine and how you can troubleshoot. Alright, let's jump into the agenda. We will start with a theoretical overview. I will explain how the Azure's Purview service communicates with Microsoft SQL and how policies are defined, how they differentiate to SQL Server permission system. Then I will give an overview over the tools that are available in SQL to analyze policies. And at the end, I will do some live analysis using SQL. Okay, so the general idea of using Microsoft Purview with policies is that you can apply permissions or have the effect of permissions that apply to any level of the resource inside your subscription. So for example, you can apply a policy to a resource group containing multiple Azure SQL Server instances, or you can just pick a given any specific SQL Server instance or even individual database, and then basically grant permissions on all of these resources within that level to a given Azure AAD principal. The principal could be a user, a group, or a service principal, any valid Azure AD principal. So, for example, one of the first use cases is to allow performance monitoring for multiple SQL Server instances. So there is a policy that you can apply to a given Azure AD principal and assign it on any of these scopes inside your subscription. So in this case, and I believe this will be the most common scenario, that you will publish such a policy on a given resource group that contains multiple SQL Server instances, managed instance, SQL Server on Arc, could also be, of course, Azure SQL database, and then any of the databases below that scope. So in theory, you can also apply these policies on individual databases, but of course, this feature is more optimized for granting permissions at scale, rather than having hundreds of policies per individual databases. So we have an external definition of permissions. I'm using the word permission at this moment, but I will change that in a second. A given set of permissions that are applied externally to the SQL engine, or that are defined externally and then apply inside the SQL. So this external definition of permissions, that's the important piece. This is where Microsoft Purview is being used as a policy provider, basically, where you define which level of access any of these persona has to the applied or to the scope where you publish these policies. So publishing is basically the term that Microsoft Purview uses for applying these policies at a given resource level. So how does SQL Server understand that there is now some access granted to a given individual? So on this slide, we can see that there's the Microsoft Purview service. That's, of course, a totally different resource provider than from Azure SQL. So we have a second box here, the SQL Server Engine. It's a separate service. So there is a communication going on between those, and the communication is that we have integrated inside the SQL engine a library from Purview that regularly pulls new policy definitions and assignments who these policies apply to into the SQL Server engine. So inside the SQL Server engine, we have a new library integrated, and this is doing calls to an external service, getting the new definition, basically permissions. So these permissions will be cached inside this Purview policy cache inside the engine, and they will then be used when any of these, we call them onboarded SQL operations, are being tried in SQL. So for example, for this performance monitor scenario, we have enabled viewing certain dynamic management views inside SQL. So those are onboarded. These specific activities, that means if somebody tries to run a DMV, select star from system DMOS wait stats, anything like that, the SQL engine will do a SQL permission check as today, but it will also check in the purview policy cache, basically, what kind of permissions may you have from external. Is there any policy that applies to this current user? Not just a SQL permission, but maybe a policy created in purview. So those two types of permission systems come together. Now, if you look at the slides, the actual term that is used in the purview world is action and not permission. So inside the policies, we define so-called actions. There is a slight difference towards SQL permissions, so let me get into that. Let's start with a SQL permission. SQL permissions, you may know, are a hierarchical system, meaning one permission can cover a range of operations. So, for example, you could say, I grant author table. That means you can add new columns, but you can also drop columns. You can maybe even change some definitions. Another example would be that we have parent permissions. That means that certain permissions are implied by parent level permissions. And let's see that, for example, here we have the author permission, which is always inherited from the control permission. And there are typically the author permission also implies creation and drop for objects inside SQL. So this is one scenario of hierarchies. The other hierarchy level, of course, is in the resource level. For example, you could have the select granted at the database scope. That means you also have select on any schema and on any table. But this is not the same as the parent permission concept. So the really differentiating factor here between the SQL permission system and the next one, the purview-based one, is that permissions inside SQL are hierarchical. So now coming to an action-based system, like role-based access control or policy-based access control, normally these systems are based on so-called actions or operations. These are very atomic operations. That's the word that I personally prefer to use. So, for example, the deletion of a column in a table is one specific action. Select from a table is, of course, another action, and so on. So, in an ideal world, all of these policy systems would have exactly one action per operation or one permission, so to say, per operation, except that the whole concept of permission is not existing. It is a concept of the action itself is being part of the policy. There is no permission versus operation. Like in SQL, you have a permission and it grants you access to multiple things that you can actually do. In an action-based system, the action itself is what you define in the policy, and by that you are allowed to do it, or you are denied. That's of course also possible. Now, we are trying is to make a SQL server understand this same concept of actions, because that's how Azure Purview works. But on the other hand, if you look in the details, you understand that the Microsoft SQL Server system is way too complex to make it feasible to actually follow this concept all the way through and at a one-to-one level. So, for example, you could consider every single system procedure would be one action, but in the end, you would come up with with policies that are hundreds of lines long. Of course, not very useful. So in order to make SQL Server work for the action-based system, we made some compromises and grouped some of these operations together and gave them some logical name, as you will see in the next slide. Important difference against the SQL permission system remains: actions are not covering other actions. So if you have one option, if you have a action for alter table, change column data type, then you have that permission, but you can't do alter table, drop column, etc. So these are independent activities that eventually will show up. Currently, we don't have these DTL commands onboarded yet, but that's how it will eventually look at. And also, to compare it directly with the first example of SQL, the create and drop would be totally independent from the alter. So if you have alter, table, option, etc., you don't automatically would have the create table or drop table at the same time. It's not inherited in the action-based system. The only sort of hierarchy that exists in RBAC, of course, is that you apply it on a given resource level, as I showed in the slides before. In the resource group, you apply it, and then it inherits down to any level below that resource group. But the permissions themselves are not hierarchical. So, after talking about all these actions, what does it actually look like in Purview? There's an example on how the SQL Performance Monitor role is comprised. So first of all, we have defined an action to connect to a database. That's the technical or the string inside the policy looks like SQL servers databases connect / SQL servers /database /connect. This is the string that's part of a policy. In fact, there is a part in front that I omitted here that defines the actual resource provider and including your subscription. But the main thing that we came up with is this part of the action string. So a connect action is not just itself the connect, it includes this path of where it applies to, so database connect. The other action that the performance monitor has is SQL server /system views and functions /server performance state /rows /select. So the interesting parts here are the blue and red parts. System views and functions, the first part of this action string here. Pardon. This is basically one of these groupings that I did purposely, which doesn't exist in that way in SQL today. All DMVs. So we have catalog views, we have dynamic management views, and we have dynamic management functions. If you grant select in SQL on a schema or on a database, you cannot differentiate between that type of view, that type of function, etc. However, for practical purposes, I came up with this system of defining a so-called system views and function action string that merges all system views and also functions, because both of these type of objects are selected using the word select. And the second part of the string in red is basically the group of system views and functions under that. So there are performance-related system views and functions. On the opposite, there could also be security-related ones. And also there are some of them that are server level that define, for example, system OS wait stats or OS info. Those are this is information that really relates to the whole server, the whole logical or physical server, versus some of the database level DMVs like index physical stats. They will really contain database specific information. So this is the second slice that I basically artificially came up here with under the system views and functions. And then the last part is just rows and select. That's the last part of the action type. So basically saying there are rows, you get all of them and you can select them. You can't update them, you can't delete the rows, you can only select. Now, as you know, system views you could not even update or delete. That's just how it works in SQL. But once we get to reading user tables, of course, instead of the select word, you could then also come up with update and delete actions. All right. Now, if you look at the fourth row from top, SQL source system views and functions server general metadata, that's another grouping that I defined here. Next to server performance state, server security state, we have general metadata. These are some of the catalog views, basically, that include access to, for example, systables, sysindexes, etc. Okay, so in all of these activities or operations, you can select performance-related system views and functions, etc., these are then part of one policy. This policy is a built-in policy that exists in Microsoft Purview today. In the future, you will also be able to define your own policies using these predefined actions. You can't make up these actions, they need to exist. We onboard them, so to say, and then they exist and can be used. And SQL Server will check both any of these actions and the relative database permissions. So for example, the second one here from top again, system views and functions, so performance state, relates to view server performance state. That's the SQL permission that is somewhat one-to-one relatable to this one. Okay, so how can we actually analyze what's going on inside our Azure SQL database or SQL Server after we onboarded policies, after we applied policies? Now, first of all, you want to understand, is my server, my database actually governed from Microsoft Purview? And there we have a new property that today in the preview version, it's the second line here, is external policy-based authorization enabled. In future will be called is external governance enabled. So this is simply a property that will give you 1 or 0. A 1 is the result if, yes, your server is governed from Purview, meaning in addition to the SQL Server permissions, Purview policies are being pulled and used for policy evaluation. So that's one way. The other way would be via PowerShell. I have the example here on the slide, external policy-based authorizations invoked using a REST method. Okay, so looking a little bit more on the internals. The Purview SDK is loaded into the memory of SQL Server. If you want to understand how much memory that one is taking, you can look at system OS memory clerks. And currently it's called memory clerk _RBAC. For GA, it will definitely be renamed. So have a look at the update and documentations then. Yeah. So the second one is on this slide is once you understand that Purview authorization basically is being used, your memory clock has a certain size, we have a way to tell how many policies are actually applied to your given SQL Server, when was the last time that they have been updated, and also we do have two different types of updating policies. So in standard, by default, policies will only be updated in a incremental fashion, meaning we pull everything that has been changed and apply the changes to our current database. But for a number of reasons, there can be a reason. For example, after a restart of a database, of a server, we do a full reload of the policy cache. So you can see what happened last time in the sysdm external policy cache DMV. That tells you how much and when was the last time the policies have been updated. Okay, so if you want to play with these policies yourself, you're testing, you probably are not so patient. At least I'm not, also for demonstration purposes. We have a way to speed things up so you don't have to wait for the next pull, which happens every 2 to 5 minutes currently. If you just change the policy and you want to make sure you see the latest state of your policy, so you can test everything properly, we have a system store procedure, sys_sp external policy refresh with underscores, and that ensures that the policy cache is being updated when you run this. And you can also choose here if you want to do an incremental or a full reload of the policy cache. Yeah, also I put here the permissions. So in order to do that, you require the author server state permission. And in Azure SQL database, since we don't have server level permissions available, you can use the new MS server state manager server role. Now, once you have downloaded the latest set of policy, once they're active, or if you just want to understand what is currently the state of permissions via purview policies. We have a bunch of DMVs, 5 of them. The first one's actually quite static. It just gives you a list of which actions currently are supported by the SQL action. So all those strings that I showed, for example, for the performance monitor role, those should be there, and a bunch more for the SQL security auditor. So you have an understanding which actions / external permissions can be used. Doesn't mean they are in use. So the next one is going to give an insight of which policy roles have been applied via policies on your current server. So if you have two SQL servers under the same resource group and a policy is applied to the whole resource group, you would see the same information everywhere. But of course, if you have different policies per server, then it depends on your given server, what you see here. So then we have other DMVs that give you the actions that are part of the given roles. The predefined roles, the built-in roles will always return the same actions, of course. In future, again, you may see different actions if you have custom roles. Now, the external policy principles catalog view will give you all AD principles that are part of a policy and have a connect permission. That's important. If a principal doesn't really have connect permission, any other permission applied via a policy would not have effect in SQL. Currently, all built-in roles have connect permissions, but again, if you come up with custom roles and forget the connect permission, you may actually not have access to the database at all, and hence not really be downloaded and have any effect of the other permissions. So that's just how it works internally, based on the connect permission that really gives you access to a given SQL server in the database. All right, and the last one in this list here is basically just a join of all the above DMVs to give you a quick way to understand who has access to your database via which role and which permissions, which actions does this role bring with it. Okay, so you also notice that all of these DMVs start with DM server, DM_server_ external policy. There is in fact a second set that is starting with database, DM_database_ external policy, etc. So just the same set of DMVs exists per database. The only difference is if you have policies that only apply to a given database and not the whole logical server, you would only see them in DM_database. So that's why we have a second set of DMVs for these policies. Okay. Then if you want to do some over the time tracing of what happened during your policy workflow, so if you create new policy in purview, when are they being downloaded, has there been an issue, or even have they been applied or have they been used for any decisions inside the permission evaluation process. Then we have a bunch of new extend events. We have external policy pull task started and finished, and also how many retries may have happened. These give you exactly what they are named for. So this pull start started gives you the endpoint, for example, where purview is sitting and what type of pull is happening. And at the finish time, we know how many policy elements we have downloaded. The security external governance call gives you information of the actual permission, of the permission effect, of the action effect, if it has been used for a permission evaluation. And we also extended the process login finish event with a new field, external governance policy authorization, that basically includes a flag if the user that logged in has logged in by using a policy connect permission, right? So this user may not have a SQL permission to connect. He may not have a login in SQL or user account. He may only have access via a policy, and that is then part of the process login finish event. Note that all of the new events are actually under the debug channel if you don't find them in the default. Okay, and then we also have a bunch of wait types internally. Hopefully you won't see too much of those, but basically we provide insight into the different stages where some waits may happen inside the SQL engine. For example, when we update policies while somebody is reading, when we are auditing information, when the pull type is running. The calls to the SDK for updating the policies is a preemptive calls, for example. So those wait types are available, but hopefully you won't see too much. And again, also those wait types in the GA version will be renamed to make them a little bit more generic. Okay, with that said, I think it's time to look at it in a live session. I will start the demo by looking at what Microsoft Purview is actually defining on this server. So in Azure Purview portal, I have navigated to the Data Policy tab. Under Data Policies, I can see 3 policies being defined in this portal. Having a look at the individual policies, I can see this policy by the name of Perf Monitor on RG allows SQL performance monitoring on a given resource group to one principal name, and the policy is published to a resource group. So that's one policy. Number 2, security auditor on RG. Auditor on RG is allowing SQL security auditing on a resource group, same principle, but it is not published. That means it's not applying to anything yet, it's just prepared. And the third one is allowing SQL performance monitoring again on on 2 different Azure SQL databases. This is not the one that I will be using for demonstration, so we can ignore this one. This is just an example of a policy of applying the same set of roles on 2 different data sources at the same time. In this case, two different database servers. So in essence, I have two policies that are relevant for me. Let me go in just to see the editor here one time. That's how it's defined. You have a name, description, and here is the statement allowing performance monitoring has been chosen. Could be any of the other ones here. And here I have chosen a resource group as the object where it applies to, and a principal name. Alright, so let's have a look what we can see from the SQL side. Remember, one of those first 2 policies is actually published, the third one will not be relevant. Okay, so first is policy external policy-based authorization actually enabled. So note that I'm connected to a server Azure SQL database AWO West EU2. That's the one that I'm using for the demonstration. The one that the third policy applied to was without number 2, so that is not relevant. But this server is in the resource group that's relevant to me. So let's see if it actually would understand any policies. This property returns 1. Okay. So from the SQL side, we can say, yes, this new ability is enabled. There's also a PowerShell way to do that. Running the statement here, I can have a look via PowerShell. Alright, there it is. So external policy-based authorization is enabled. It's set to true. Okay, let's continue in SQL. First thing, yeah, we can have a look at the existing token and perm user store. This is not a new cache, so let's just jump into the new memory clerk. So it is being used right now. It's fairly small, 320 KB. I have not seen it bigger than a megabyte so far. We have this first DMV specific to our feature, DM external policy cache. Let's have a look what this one says. So this one says cache is ready, And last time it has done an incremental pull. Number of cache policies is 1. So this is so far correct, because remember, out of the 3 policies, only 2 really would apply to this certain server, but one of those 2 is actually not even published. So let's have a look at some other DMVs in this state. The first one, DM external policy actions, returns me a static list of potential actions that can be used for SQL. The provider string is always the same. The main interesting part is the namespace and then the action type. So you can have the connect permission on a whole server or on a database. The server would be relevant for managed instance and on-prem server, for example. And then we have all these individual actions that I talked about on the slide, applying to these for different groups of system views and functions. So here we see performance state, server performance state, and database performance state. And then we see security state, database security state, and server security state. And so on. We have database security metadata and server security metadata. And then we have a specific type of cryptographically secured metadata on the server as well. These here, schemas, tables, rows, will be relevant for the data reader role. And again, we have some specific ones here for DBCC commands. Also, extend events will be coming, as you can already see from the metadata. All right, so what roles have been published or potentially exist? So in this case, actually showing all the roles that can be used. Those are the ones that are in preview right now. Those are the ones that work for SQL, read, performance monitoring, and security auditing. Now we can join them, or we can use this ready to go statement. So we can see there's one entry. This is my principal ID, Andreas Wolter. The internal role named the performance monitor has been applied on the whole resource group, of which this certain Azure SQL database is part of. So that's why it shows 1 in the downloaded policies. Now let's go back to the Purview portal. So this is the one that has been published to the resource group, performance monitoring. Okay, we just saw that in the cache. The second one, security auditor, has not been published, so it's not applicable yet. And I will do that. I will do the same here and apply it to the resource group. It has an alias name, project alpha RG. That's basically the resource group where this server is inside. All right, so it's published. Now I can have another look and see if it already pops up. Chances are not so high, because as I said, there is a schedule behind. Every so often pulls down new policies. So while I'm talking, let's quickly, before I refresh or force the refresh, go and open a new extend event session. So I'm using the new extend events policy pull task finished, retries, and started. And I will start this session right away. So now we have a running X event session. Now I will go back to the script here and run the force the reload of the policy cache, the local one of this Azure SQL database server. So and I'm also already having another look here at the system exit requests. And I can show you here that we have this new wait type basically that just happened because of my policy refresh. Super short, and that's the way to catch this one if I call this one right after initiating this call. So let's see, has anything changed in my cache? We can see it's again ready. It shows cache policies are 2. It also shows incremental. That to me is a sign that right after that force reload, probably we had another automated incremental refresh. Let me just run this piece again here to make sure, to prove basically that really the reload with force will be used, and it also will show up in the cache. Alright, you can see now. If I do it immediately afterwards, yes, it's the last pull time was a full because I did it. It was not the system one. All right, so the X events now had some chance to catch something. Let's have a look at the data. So session was running, right, it's here. And let's get the session data parsed out. So on top is the XML presentation. We can see here the individual events. It's a bunch because we did 2 cycles. So let's just have a look at the latest information here. You can see that here was a pull task started, and then there's a retries event which shows me some message here, policies being updated, can be written. For the starting, we also see the endpoint where our Purview service is waiting, and when it's finished, the finished event also shows me how many policy elements internally have been downloaded, and of course in this case the session. Alright, so that has happened in the background. I can stop the session now and even kick it around. Let's last have a look at the, actually once before that we do here. We have already shown the incremental update. I think we have seen it in the DMV, but this is basically the other way I can do it, to not force a full update if a refresh is sufficient. Now I mentioned there are some new weight types. We can look at SystemOS weight stats with these specific weight types that I had on the screen. So yes, some of them have occurred, actually only one of them, Purview Policy SDK Preemptive Scheduling. Now this is over the whole lifetime of this server here. If I would look at the session ID 58 is the one that actually initiated these force updates a couple of times now in my demo. I can see the weight type here as well. It's here number 3. It's not really dramatic. There's a tiny piece of the overall session weights. So those are the sources that we have today to analyze Azure Purview policy communication. Okay, let's recap what we have seen in this session so far. So using these external policies, we can control access to SQL Server Azure SQL database using the Microsoft Purview service, which is being used to pull down the policies, the latest ones. The code to parse these policies and to then do the permission checking is integrated in the Purview engine, which then, according to which or depending on which command is used, the so-called onboarded activities. In this today we have the performance monitor, the security auditor, and the data reader. So those commands that have been onboarded to the external policy authorization, they will have a double permission check, basically asking, do you have SQL permissions or do you have external policy-based permissions? And if any of that is true, you will get access. But also if any of those is denied, you will be denied access. The policies are actually downloaded and cached locally, so we don't reach out to Azure Purview every time you're trying to evaluate permissions. Obviously, that would kill permissions, so it's cached every couple of minutes, but it can also be forced with the system external policy cache if you want to make sure right now that all the policies are up to date in your servers. And you can analyze the state of the policy cache with DMVs and the download events with X events. Okay, I hope that was interesting to you. I have a few resources here that have some of the details, how to set the whole thing up, the announcements with some of this information, so you can follow those things along yourself. Thank you very much for joining this session. Remember, here are some prizes to win at Data Platform Summit. Good luck and see you next time.